Hi, welcome to part 3 of our problem solving tools videos. We covered Pareto charts in the first video, which was a tool we used to summarize data to establish which issue should we work on to get the most benefit for the least effort. Then we covered operations process chart, which was a 10,000-foot look at the operation, recording just the assemblies, operations, and inspections. And now we're going to look at a flow process chart. So flow process chart is, I would say, maybe an extension of an operations process chart, except that it has a lot more information. Here's an example of a flow process chart right here. And additionally, a Pareto chart you're going to practice in a lab later on in the quarter. An operations process chart, along with some bill of material reading you're going to do, will be a homework assignment. And we're going to do an activity in class where you will build a flow process chart, analyze the information, and then build the proposed flow process chart. To practice that as well as use it hopefully in your project if it's appropriate. So for a flow process chart, we have a lot more information, a lot more data about the process than we do in an operations process chart. We have both the assembly and operations designated by a circle and the inspections designated by a square, just like we do in the operations process chart. Additionally, though, we have information about transportation, which is denoted by the arrow, temporary storage, which is denoted by a D, and permanent storage, which is denoted by an inverted triangle. And you can see these are all listed here. Here's a description of all of the steps, very similar to the operations process chart, which also sometimes is called an outline process chart. But additional information because we have transportation, temporary, and permanent storage. So I'd like you to take a minute and think about what is the difference between temporary storage and permanent storage. How would you define temporary storage? How would you define permanent storage? Why don't you put the video on pause for a minute and see how you would define that, and maybe think about it in relation to our Toyota lab that we did the first week of class. I'm going to go ahead and keep talking, so press pause if you want to think about that. But how I would define it is permanent storage and temporary storage is we make some both physical and system transactions so that we denote parts moving from one area to another. So in temporary storage, I would classify it as WIP, work in process. So think about the Toyota lab. We would count up our WIP at the end. We'd have several workstations, whether we were in the traditional or the lean manufacturing mode, but we didn't delineate whether the temporary storage was at the first stage in the process or the last stage in the process, right? It was just all within work in process. Versus permanent storage, we would denote exactly where it's at and that we would probably expect it to be there maybe for a little bit of time. In work in process, it's only going to be there waiting for the worker to work on it, waiting for the equipment to have capacity to work on it. But in permanent storage, we might want to have some safety stock, some level of material there so that we don't stop the production line. So in terms of our Toyota lab, the permanent storage would be, for example, where the batteries were stored, where the chassis were stored. And when we move them from the trays or from the storage units out into work in process, that's where in system a transaction would be made to show the financial aspect of that product moving or that material moving from raw material into work in process. But in work in process, it's just like one big lump of information. You'll learn a lot more about that in production inventory control, IME 410. That's where you learn about economic order quantity. How much of that raw material do we want to have on hand given our production time, given our lead times, etc. But that's the difference between temporary and permanent storage. So now let's look at this flow process chart. So let's start off with looking at what the headers are here. So it's very important that you have all this information about the process so that we can come back at some later point in time, whether it's still JP Denton that is going to come look at it, he can refresh himself about the analysis that he or she did, or someone different is going to be taking a look at this particular area. They know who to talk to if they have particular questions. They can see what area, what process was looked at, a description of the process, what date it was, what organization it supports. This is a nice summary of all the detail down here. So we can see the number of operations, delays, storages, etc., how much time was at each one. So you can see different from the operations process chart, in addition to just listing the number and description of the steps, we have data collected from observation about the time and then again the total distance traveled here as well. And then you can see the detail listing here, and it goes across the symbols here to tell you which one it is: transportation, inspection, permanent storage, etc. Tells you how much distance was traveled and how much time was spent at each stage or at each step. So again, we've gone out and collected data about the process. And then here could be some notes as you're collecting the information too. And then you can also see it tells you that this is the present method. So this is the way things are currently happening. And we'd want to record that so then we can do some analysis of this data to see, okay, well, based on the information that we see, what are some improvements that we might make? So we might look in here and say, well, there are 5 transportations out of, it looks like about 20 steps. That seems like a lot. Maybe we could reduce the number of transportations. We also see that transportations take the most time and travel over 1,000 feet, I think is what that is. So is there something we can do to reduce the time and distance traveled? Next, I see operations takes 90 minutes. Well, that's 7. So which of them take the most time? And is that something that I could look at? Or is that the appropriate number of operations? We have 4 inspections versus 7 operations. Do we really need that many inspections? Why are the delays happening and how long are they? These are just all things you would want to look at. So 2 things to note here. Number 1, there's an Excel template of this flow process chart posted on Polylearn for you so that you can use it for the in-class activity and for your project, assuming that you use a flow process chart for your project. And then additionally, there's a document that is a list of questions to think about and to ask as you're reviewing a flow process chart. Really, in my opinion, it could be for any improvement process. The list of questions doesn't have to be directly related to the flow process chart, but that'll help you think more critically about this information and how to go make some improvements. Okay, so I think I've covered that. And then if we do the proposed, you notice we would not have an X on the present, we'd have an X on proposed, have the proposed information that show the differences with maybe some notes here about what we did and why. So again, this is a flow process chart, gives a lot more information, more detailed as far as transportation, storage, temporary, both temporary and permanent. The more data, it has the distance traveled and the time, so that again, using it to summarize information so that we can look at this area to go make some improvements. And you'll have the opportunity in class to practice this with some information that you're going to be provided, so that you create the flow process chart from the information provided, analyze it, and then make some proposed changes and create the proposed flow process chart as a result of those proposed changes. And then here we also see it's material or man. Well, we can really have a flow process chart for the worker. We can have a flow process chart for the material, or we can have a flow process chart for the equipment. Most typically flow process charts I've seen are for the material, but it could be very applicable for work or equipment too, given the particular situation that you're looking at. Okay, so that ends our 3rd problem-solving tool video. The Pareto chart, again, helped us prioritize what issues we should work on to get the most benefit for the least effort. The operations process chart gives us a 10,000-foot view with the number of operations and inspections and a short description of each process and how it's all put together. And then the flow process chart gives us a lot more detail. It has additional data such as distance traveled, the time at each step, includes transportation and storages as well. And the last one we'll be talking about will be a flow process diagram. Thank you.